It started about 3 years ago when we got a disclosure of innovation from Habib and Martin about their new driven energy pile joint, which enables the exploitation of geothermal energy from the foundations of a building.
There are various ways we can get this energy from the ground. One way is to drill boreholes, which is known as energy wells. This technology has been around in Norway for many years, but we have now challenged this technology and improved it, where we are looking at utilizing foundations of a building to get the energy out. We build a lot of buildings in Norway, and most of them, they are resting on pile foundations. So pile foundations are like a column under a building supporting the structure.
One type is cast-in-place pile, which is cast at the construction site. Basically, in this type, you drill a hole in the ground and then put the cage and the pipes inside it and then fill it with concrete. But there is another type, which is called precast type, which is cast at a concrete factory in segments, and these segments are then transported to the construction site. The maximum length of each segment is 12 meters due to transportation reasons, because that is the maximum length that a truck can carry. Then after these segments are carried to the construction site, we need to do small preparations on the pipes that are circulating the liquids inside the energy piles. There is a steel joint between these segments that connects the segments together so that we can build longer and deeper energy pile foundations. And at these joints, the joint should provide both structural integrity and at the same time connect the heat transfer liquids in a way that no leakage happens there in the pile foundation. So it should be leakage proof. Coupling the pipes is very simple in the type of precast concrete energy pile foundation that we have developed. It uses a simple type of pipe coupling that can be used to connect the two pipes that come from two different segments of energy piles. So the energy piles that we have developed come in two different sizes. One size is 27 centimeters and the other size is 35 centimeters. In the smaller size, we have only two pipes, but in the larger one, we have four pipes that can carry the heat transfer liquid in the energy pile foundation. For the installation of the piles, we use pile driving rigs, which are basically machines that have large hammers that apply impact loads on the pile segments and install them in the ground. So basically, these pile driving rigs can install several segments in a day. So the installation process of driven energy piles is quite similar to normal pile foundations, driven pile foundations. The only small difference is that when we install each segment, we should connect the heat transfer loops to the segments that are coming from the top. So we have a joint that is initially connected from the bottom segment to the top segment using male and female dowels and some pins. So these pins are simply hammered to the holes that are at the side of the joint to lock the joint in a way that it can transfer both the axial compressive loads and tensile loads and also the bending. Then after these two segments are connected structurally, we should connect the heat transfer loops together. The connection of heat transfer loops, as I said, is pretty simple. We just need to use pipe couplings that are commercially available that are known as fusion welding couplings. We put the fusion welding couplings on the pipes that are coming from the bottom segment, then we put the top segment on top of it, and then we simply pull up these pipe couplings in a way that it takes the overlapping distance between the two pipes and connects the pipes at the interface between the joint. Then after the coupling of the pipes is carried out, we need to use shielding plates to cover these heat transfer loops to keep them safe from the severe frictions that are acting on the pipes while the pile foundations are installed in the ground. These shielding plates are simple types of plates that are covering the sidewall channels of the joint, and then they are riveted using available types of rivets so quickly that it doesn't cause any delay for the installation of the pile foundation. Then after the two joints are connected, the pile driving rig can continue its hammering process and can install the next segment. So this process can be repeated for several segments, and we can connect lots of segments together in a way that we can build longer energy pile foundations in the field.
So my role in this is the business development. So they do the research, and I try to make this commercial. So in this case, it's talking to the industry, talking to the existing industry actors, talking to entrepreneurs in order to get the interest from the market, and also trying to license this to an existing actor on the market. So we've been in a discussion with several companies, both in Finland and in Denmark, and we're also trying to get in touch with companies in the US and in the UK to see if they want to license this, and several promising leads. And hopefully we will be able to close this in a few months.
The good thing about this technology is that we can get energy out of the ground, but at the same time we can also collect the heat from a building and store that in the ground.
For any building that would use precast concrete piles to begin with, at any rate, if they use this new joint instead of traditional joints, you can harvest 60 to 70% of the energy you need for heating and cooling in the building from the foundations that are there anyway. They're prefabricated, so they're cheap and efficient, and you're driving them into the ground, so you don't have to consider any waste at all. And it's much cheaper and much quicker and much more efficient than drilling and then casting the piles in place. And it's also, it gives you the opportunity to have much better quality control, because you can control each pile before you drive it into the ground. And of course, you're reducing carbon emissions significantly as well, because you're using much less energy for heating and cooling.